This is Pong. Ah, right. Sorry. This is Pong. If you don't believe me, then let me show you. And if I show you the live scene tree, yeah, there it is. A single node, and yet, the Pong, it plays. If you're asking what on earth is going on or how this works, then don't worry. I'll be explaining how we go from a normal looking Godot project to, literally just one node that doesn't even have a script attached. So this is our starting project. For this recipe, we use 1 color rect for the background, 3 sprites, 1 for the ball and 2 for each paddle, 3 area 2Ds and collision shapes for the ball and each paddle, and 3 scripts for the player paddle, the AI paddle, and the ball. In our paddle scripts, we add some logic to move the paddles, the player script gets some input logic, the AI gets some logic to make it follow the ball. Next, we add movement logic to our ball, connect its area 2D to allow it to bounce off the paddles, and add a score function that resets the ball, and finally, we add an input key to start the ball moving. This is our Pong base. But frankly, if you ask me, it's too many nodes. If only there was some way to make this work without using collision. Instead of using area 2Ds, we can calculate the positions of our paddles and ball, turn those coordinates into rect2i's, and then use rect2i's intersects function to find out if they're overlapping. Now all we have is a root node, a color rect, and 3 sprites. It still feels like too many nodes though. If only there was some way to draw images without using sprites. So, in the canvas item class, there's a function called draw that can be overridden to draw on your screen. Canvas item is inherited by both control and node 2, which means that any UI node or 2D node has this function. There's a collection of functions you can use to draw shapes, and we're going to be using drawLine, because everything in Pong is just some kind of rectangle, which is just some kind of line with a specific width. We're already calculating the position of the paddles and the ball for collisions, so we can use that same math to calculate the positions that our lines need to be drawn at. As long as we make sure we're calling the drawLine function and QRedraw in our process, then our ball and paddles will continually update to the correct position. We've been using the position variable in our sprites to calculate their position, but this is just a vector 2, so we can just make 3 vector 2s in our main node and use those instead. Once we've moved all the code into the main node, set up our draw functions and position variables, we can click play and behold, Pong from a single node. It's beautiful. Except, isn't there too much code in this node? If only there was some way we could move all this code to somewhere else and call it from. So, because functions are just variables, we can actually just move almost all of our code to a separate location. I don't want to have a second node in the scene, so we're going to put all of our code in an object, which I am naming Pong backdoor. Unfortunately, the physics process, input, and draw functions that we're overriding are inherited from the node class, and objects are, well, a little bit earlier in the family tree than nodes. So, in our Pong backdoor, we're going to make fake versions of these functions that have an extra underscore at the start, just for clarity. And then in our main node, we're going to make callable variables that we will set to be equal to our fake versions and call them at runtime. We need to pass in the main node for our draw function because you can only call draw from a canvas item node. The last thing we need is a third script to set this all up. This Pong hacker script will do the actual work of creating the Pong backdoor and setting the callables in the main node. I'm trying to minimize the amount of code visible, both in the editor and at runtime. So while I could make this Pong hacker a node in the scene tree, I'm instead going to make it an autoload that frees itself once its work is done. And while we're here, we can also remove the script from the main node and have Pong hacker set it at runtime instead. As a side note, I tried removing the Pong backdoor object after the callables had been set and it didn't work. Godot needs you to keep the source of the callables instantiated. If it gets freed, then any callable variables referencing them will throw errors when called. Finally, a Godot game with only one node. It's beautiful, flawless, majestic. Except, well, it would be nice if instead of a control node, we just had one of those default gray nodes. But if we do that, then it won't be a canvas item, which means the draw function will stop working. It's not like there's some other way to display images on the screen that we could be using. This is the RenderingServer class. At any given point, when you are displaying anything on screen, Godot is actually quietly running a bunch of code on the RenderingServer. And thankfully for us, Godot exposes a bunch of functions that we can use to directly call some of this code, which can be done from literally anywhere. Which means we don't even need nodes anymore. For now, we're going to use this to replace our control node with the default zero functionality node. The documentation does a great job explaining the inner working of this, but hopefully explain it quickly. Rather than using sprites or draw calls, we're going to create images on the RenderingServer and then store references to those images as an RID, Resource Unique Identifier. Resource ID? Then we will continually tell each image where it needs to be on the screen by calling a function on the RenderingServer, which takes an RID and a transform 2D. For those of you that don't know maths, a transform 2D is just a variable that can store a position, rotation, and a couple other bits of data to do with moving shapes around. The other thing we need to do is attach our created images to a canvas. The 2D RenderingServer functions off of its own tree of viewports, canvases, and canvas items. The main viewport has a primary canvas, and our images are canvas items that we attach to this primary canvas. Also, the viewport and canvas item that the RenderingServer uses are not the same as the viewport and canvas item nodes, but I'm 99% certain that when you make one of these nodes, the RenderingServer is making a corresponding version, and the nodes are internally storing an RID that they use to control their RenderingServer versions whenever you do anything to the node version. Anyway, we can get the canvas RID we need by calling node.getTree.getRoot.FindWorld2D.canvas. As long as we attach our canvas items to this canvas after creating them, then they will display properly. We also have to move our images to the correct position at runtime, but we were already doing these calculations for our draw calls, so it's a simple matter of replacing the draw function with the corresponding RenderingServer function. With that out the way, we can finally switch our main node from a control to a majestic, gray default node. Finally. Wait, earlier, did she say for now? What do you mean for now? Don't look at the runtime of the video. What could possibly be left to strip away? There's only one node left. Look at the scene tree at runtime. You see this? This is the window. It's the root of the scene tree. Remember earlier when we got the root viewport? Yeah, that's the window, which is this thing right here. This is the thing that the game is displayed in. And that's the only thing that we actually need. We don't even need our default node. So where do we store our code if we don't have any nodes? There is a class called the SceneTree. This class is in charge of managing the scene tree, alongside a bunch of other responsibilities that I, frankly, don't have a full grasp of. But most importantly, we can replace it. In the project settings, if you take advanced settings, under Application, Run, there is a setting called Main Loop Type. By default, this is the SceneTree class. So, if we just make a class that inherits from SceneTree, we can put all of our game logic in that class, and then replace SceneTree with our custom class, which I'm calling PongTree. This will mean we will have just a single script and a single scene, with a single node in, which, at runtime, we will free, because we don't need it anyway. In our RenderingServer functions, we can remove the getTree when getting the canvas for our canvas items, because getTree just gets you the scene tree, which this script is. We're already in the scene tree class, we're inheriting from it, so we are the scene tree. We also need to add our own input check in the process function, because input is a node function, which means we can't use it anymore. Finally, a Godot game with actually 0 nodes. It's so pure, so clean. I can even check that there are 0 nodes by going to the debugger, opening the monitor tab, and scrolling to the node count. Oh, that's right. There is 1 node left. It's the window, which, as it happens, inherits from node. Okay, from this point onwards, full credit to figuring this out goes to my friend Mio. I was perfectly happy with my window node, and then he looked at it and said, bet. When asked if he'd like to commentate any of this section, he said, I'm not explaining shit. The code is self-explanatory and the docs are amazing. Anyway, we're going to start with our scene tree. It turns out that one of the things it does is instantiate the window, which means we can't inherit from it in our pong tree class. Instead, we're going to inherit from main loop. This is the main loop. It's Godot's main loop. It has some fun quirks, like if its process or physics process ever returns true, the game closes, the main loop literally ends, which I think expresses how much of a main loop this main loop is. So earlier when we replaced the scene tree in the main loop type setting, it turns out that anything that inherits from main loop is also valid, which, I mean, makes sense for setting called main loop type. With that done, we now need to look into replacing the window. And I say replacing and not removing because we still need some of the functionality that it provides. The window is where our main viewport is, which means that without it, we will have to make one ourselves. We can do this by calling RenderingServer.viewportCreate. We also need to attach a canvas, which can be done by first making one with RenderingServer.canvasCreate, and then RenderingServer.viewportAttachCanvas, passing in the RIDs for our created viewport and canvas. Our viewport needs a little more housekeeping from here. We have to set its size, attach it to the screen, and set it to be active. We also need to set the window size. For fun, we can change the name of the window using displayServer.windowSetTitle. This will get us our functioning game, but we want to make sure that it closes properly. So we're going to replace the window set window event callback with our own function that sets the main loop to end on the next process function call. Alongside that, to avoid any memory leaks, we free all of the RIDs that we've created when the game is closed. And finally, with that done, we can admire our work. You may not like it, but this is a video game. So, sadly, Godot will not run without a scene, so we can't have only a single script for our file system. There is a fork available that enables running Godot without a main scene, but I've already said that I'm happy with how far I've come, so I don't exactly feel compelled to learn how to build the game binaries from source from a fork. I took you through a bunch of levels, gradually getting lower and lower in functionality, but you don't have to do all of these at once. The rendering server is something that you're only recommended to look into if the CPU is the bottleneck, and you have a lot of visuals on screen that you want to optimize, like thousands of bullets, for example. I also could have looked into the physics server and used that instead of calculating the paddle and ball collision myself, but we made that change pretty early on, and I didn't want to go too low level too quickly. The pong hacker I made was pretty clever, but it's situational. Sometimes you want to be able to execute code on a node from a completely isolated location, but most of the time you want to be able to see your code easily so that you can tell what it does. And in that situation, it's way more helpful to have it all in the same node or the same scene. The main loop and scene tree are things that you could change if you wanted absolute total control over your game, but I don't actually think that helps make games any faster or better. In my opinion, the main priority to optimize for in game architecture is making something that's easy to change later. And I'm pretty confident that there are almost no situations where you could design a version of the main loop or scene tree that will actually help you do that. If you made it this far, I hope you learned something. And if I said anything wrong, just feel free to correct me. I'm not 100% on some of this low-level stuff, especially considering I wasn't the one who figured the last bits out. Thanks for watching. Vid's definitely over now. Don't look at the runtime. Okay, look, you can run Godot from the command prompt. I'm actually not going to explain this because it already feels firmly in the territory of you're only going to want to do this if you know how to do it already. It does actually mean you can delete the remaining scene from the editor though. Mission accomplished.